Okay, we're going to go ahead and practice together by doing 3 more examples. And in this example, we're going to once again find the volume of the sphere. Except notice this time the diameter is given and not the radius. So I'm going to go ahead and write diameter. Hold on one second. Okay, so if we know the diameter is 16 feet, then that means the radius is half that amount. So the radius is 8 feet. And you need to make sure when you plug the number into the formula that you use the value for the radius and not the diameter. Okay, so volume equals 4/3 times pi times r to the third power. All right, so let's go ahead and start with r to the third power. So that's 8 to the third power. So let me rewrite all this again. 4/3 times pi times 8 to the third power. And 8 to the third power is 8 times 8, which is 64. And 64 times 8 again would be 512. Okay? So once again, depending on what type of calculator you have, if you're just using a basic calculator, you probably need to do like what I'm doing, where I write it as 4/3 times 512 over 1. And I go ahead and I multiply the 512 times the 4 first, and then I divide that answer by 3. So when I multiply 512 by 4, I get 2048. So that's 2048 divided by 3 times pi. So now I'm going to go ahead and I guess I could leave it like that, or I could go ahead and rewrite it as a mixed number. If I rewrite it as a mixed number, I get 682 and 2/3, or I could say 0.6 with the bar over it, pi, and I need to scroll back up to see what our units are. They are feet, and we're talking about volume, so my answer is in cubic feet. So this is my exact answer of volume. Now to get the approximate, I'm going to take that number and I'm going to go ahead and multiply it by 3.14. And since I can't really put a mixed number into my calculator, what I did is I went back to that improper fraction, 2048 over 3, and I did 2048 times 3.14, and then I divide that answer by 3. So my approximate answer, rounded to the nearest tenth, is 2,143.6 cubic feet. So that's my approximate volume of that sphere. On the next example, once again, we're given the volume and we have to work backwards to find the radius. So we're still going to use the same formula, but now we're going to plug in the value for V instead of the value for R. So it's 4/3 pi r to the third power. So I know that my volume is 36 pi, and so now I'm going to try to work backwards to get that r isolated. So I'm going to start by dividing both sides by pi, because that's the inverse of multiplying by pi. It cancels out on the right side. It also cancels out on the left side. Then I have 36 equals 4/3 times r to the third power. Before I deal with r to the third power, I need to undo multiplying by 4/3, which means I'm going to divide by 4/3. Remember, dividing by 4/3 is the same thing as multiplying by 3/4. So I'm writing it now as 36 over 1 times 3/4, because remember, dividing by 4/3 is the same thing as multiplying by the reciprocal, and the reciprocal is 3/4. So now I'm going to multiply 36 times 3, which is 108, divided by 4. That's going to equal radius to the third power. When I simplify 108 divided by 4, I get 27. So now I have 27 equals r to the third power. And the only way to undo, or the inverse of raising something to the third power, is to take the cube root. So now I want to know, what's the cube root of 27? What number times itself again is 27? And that is 3. So I get radius equals 3 meters. Okay, we're going to do one more example together, except this example is actually a hemisphere. So the only difference between, sorry about my little one screaming, the only difference between a hemisphere and a sphere is that a hemisphere is exactly half the volume of a sphere. So all I have to do is take that formula for finding the volume of a sphere, and now I'm going to go ahead and just multiply that by a half. So I'm putting times a half out front. All right. So take note of what we have here. We have the radius, and we have the radius is equal to 12 feet. So I'm going to use this formula. Remember, the only thing that's different is that I put this times 1/2 in there, since a sphere is literally, or a hemisphere is literally a sphere cut in half. So I'm going to use the formula, and I'm going to plug and chug. I'm going to put the 12 into the formula for the value of r. So I get, by the way, I could, if I want to, go ahead and multiply 1/2 times 4/3. And 1/2 times 4/3 is 4/6. So I'm just going to go ahead and write that. 4/6 times pi times 12 to the third power. Now we know exponents come before multiplication, so I have to raise 12 to the third power before I do any multiplying. 12 to the third power, where are we here? Sorry. Okay, 12 to the third power is 1,728. So I get 4/6, and remember I can write in any order that I want, times 1,728 times pi. So now with my calculator, I'm going to go ahead and multiply the 4, which is the numerator of the first fraction, by the 1728 in the second fraction. And I can go ahead and multiply my denominators as well, because 6 times 1 is just 6. So I get 6,912 over 6 times pi. And if I simplify that, 6,912 divided by 6 is 1152. So the exact volume is 1,152 pi cubic feet. Volume is cubic units. In this case, it's feet. Sorry about the noises. All right, last step is to get the approximate volume. So I'm going to multiply 1,152 times the approximation for pi, which is 3.14, and I get that the approximate volume is 3,617.3 if I'm rounding to the nearest tenth, and that is cubic feet. So this is my exact answer, and this is my approximate answer rounded to the nearest tenth when I multiply by 3.14, which is the rounded version of pi. Again, let me know if you guys have any questions, and you can also watch the videos that I'm attaching from Khan Academy if you need more examples and additional instruction. Good luck.